Good evening, everybody. This is Cris, Micheli, and John Griffiths from NeuroTechX Toronto, and welcome to the third event of the series. This event is focused about the industrial and academic synergistic work. And we know that in Canada, we have a lot of startups and a lot of initiatives, especially within NeuroTechX, so that we can tap into them. And we have John Griffiths with us. Hi, John. Good evening.
Ciao, Cris. How
Hi
are you?
there. I'm very good and very excited about this episode because we have great guests. We have three guests tonight. We have Maciej from BrainAttach, and we have Hanna and Shanjay from Axcessiom, and we speak a little bit what they do about what they do tonight. But I want to thank the audience for being persistent with us, and I know there is a lot of interest in the community. And we have also other initiatives within NeuroTechX. For example, on Thursdays, we have, as you know, the NeuroTechX from San Francisco. It's a technical event, and I love the initiatives that they are, carrying out there with Alex. So I guess you attended, and I attended a couple of times. There has been a couple of good questions there, so I'm excited also about their program in San Francisco.
Yeah. On that note, I'm dropping in tomorrow for the SF call because there's some interest in some sleep EEG analyses, and I do not profess to be an expert in sleep EEG, but I am, like a number of people, getting into it.
Yeah.
And so I think we're gonna hopefully have some knowledge sharing and some kind of skills sharing, and get some complementary thoughts and expertise on sleep EEG. So that will be something you could catch us on the SF call if you drop in tomorrow evening.
I'd love to. And it's interesting how many people in Toronto and San Francisco do EEG recordings, and how many of them do BCI, brain-computer interface, as well. A lot, quite a lot, right? So I know for sure that
it's the flavor of the day.
Absolutely, and then this is on the crest of the wave, and I know for sure that you're involved with the Eeg Notebooks, and that's a great initiative too, right?
Yeah, obviously I'm a big fan of Eeg Notebooks because I've been putting a lot of time and effort. In addition to other great people, we have. If people are interested, we do have a regular developers meeting that is kind of open to non-core developers if people want to join us and kind of talk about some specific part of the code base or application ideas they have. Eeg Notebooks, for people who don't know, it is a kind of a BCI, like mobile BCI, but it's also, the way I think about it more, as a software library for doing cognitive neuroscience experiments with mobile technology. And one of the things that is kind of differentiates it a little bit from other tools is that we're more aimed towards offline analyses, as in so not necessarily kind of real-time decoding of the kind that you've been doing in the past, and more kind of standard fair visual experiments, auditory experiments, things that we understand well from the EEG cognitive neuroscience community, making those easy to run and easy to kind of run on your laptop and analyze the data and record the data with a Muse or a Neurosity or those kind of devices. That's Eeg Notebooks in a nutshell. If you need more than a nutshell, there is about 1 hour presentation on the website that's at the top of the documentation. So if you want to hear me talking for an hour about Eeg Notebooks rather than 2 minutes, then it's there for you on the web on YouTube.
I'm sure this is super exciting, and applying machine learning algorithms to offline data pre-recorded with low-cost accessible devices, like you mentioned. It's really interesting, and also that you and your team put up this effort of visualization and then easy access also to these open source libraries. This is a great job. But you mentioned this is offline analysis. We have Maciej Rudziński from BrainAttach tonight, and they do online analysis with BCI. So maybe that's a great connection to have Maciej explain what's the difference between these offline methods that you guys and your team use on Eeg Notebooks, and see what Maciej can do behind the curtains of his startup IP to make this online analysis, timely, especially when you have to deal with very sluggish reaction times of the brain when you capture, signals, EEG signals from brain head-mounted device. So I'm really curious to know what Maciej has to say about that. What about we invite him on screen? But before doing that, I would like to, again, give a presentation about the NeuroTechX community. So allow me to share our site. Can you see my screen?
Yep, it's come up.
So do you see this is neurotechx.com. This is our landing page, and then you have a lot of information about the community and then the mission of the community of NeuroTechX, which is centered and focused around these three pillars: community, education, and innovation. So we leverage a network of thousands of people around the world. And I guess the most important part to be part of this community, which is a free membership, it's here. So if you scroll down below the map that you see here, you can click on this button and join the Slack channel and then be up to date with all the initiatives around the world and even found your own chapter.
You got to get on the Slack, guys. You got to get on the Slack.
This is super exciting. And then we get a lot of information also for our professional goals on the Slack. So
absolutely.
I've been, involved with NeuroTechX since a year now, right, John? And I've been learning so much. So I'm honored to be part of this community. And there is so much going on in neurotechnology right now.
Mm-hmm.
But, without further ado, I want to have Maciej explain what his innovation is about. So I'd like to invite Maciej on screen.
So Maciej is calling from Poland, and the time in Poland right now is...
Oh,
hi, Maciej.
Nearly 3 o'clock in the night.
3 o'clock, yeah.
We're honored to have you, and thanks for taking the call tonight.
Yeah, with great pleasure. That was a nice question about the live performance of algorithms. I'm quite happy to help. It's not my domain, it's Adrian's, but I also can ask him because he's rewriting all of my code, which used to be in MATLAB. I'm sorry, to JavaScript and C.
So Maciej, you're based in Poland. Which city are you at?
Warsaw, that's the capital.
That's great. And your company is called BrainAttach. Do you want to tell us something about the company and then your IP? Show us some, content about your company?
Yeah, I have a presentation for you, but I started working on all of that 10 years ago, maybe 12, when I was a student. So the project grew and grew and grew until I met Yevgen, my co-founder, which is an engineer, and then from BrainAttach. But maybe I will go to the presentation. I think it will be better. Give me a second. Okay.
Yeah.
Maybe you could also give us a bit more of that little bio as well, Maciej, that you just gave us a teaser.
So I'm CEO of BrainAttach, but by training I'm a neuropsychologist. But I retrained myself in coding and statistics. So I now specialize in signal analysis for EEG, but also for business customers in insurance and other things, because at some level it all starts to look the same. And why it's important, I will say later, for sure. So I will present what are we doing. So we are creating a headband for gamers and for created, and this is a live picture of the headband. It's made to last for quite a long time. if you can see, it's on the back of your head, so that will not obfuscate your face. It should last 8 hours, so you can play continuously for quite a long time. We have 4 channels, and we are sending 2 kbhertz for each channel of raw data. So even after all filtering and everything, we still get 2 kilohertz. So it should be, because it's very important to have high quality for us of our data. That's our PCBs, and we should start selling devices in 2 months to people.
Maciej, you're very faint.
Yeah, I think your mic is cutting out a little bit.
Okay, I will try to do my best.
No, I think maybe that mic isn't. Did it come unplugged? Is it loose?
No, it should be good. Did you hear me now properly?
There you go. Yes, come back.
Yeah. Okay, so I'll keep it like that.
Okay.
So the first thing to improve something or build is to be able to measure it. And in our case, the most important thing is what we are measuring. I will show a small clip from the left.
Maciej, you can try unplugging the microphone. I think we have difficulties listening to you.
So how it is now?
It's very faint.
Still, it's very faint.
Yeah, now it's good.
Okay.
Yep.
So we'll keep it. The second microphone. Okay, so if you watched last year's Neurotech Gaming, you know why this is Left 4 Dead. And I want to say what exactly we are measuring. Here, let's concentrate on this panel. We are measuring avoidance and approach reaction, and a little bit of arousal, which is also needed to understand what's happening in the game. So here we are watching somebody playing for the first time on a new map. So he's in avoidance. But once you get used to the situation, see what other people are doing, your reaction is slowly getting back, your arousal is getting down, and he should get back to a normal state, where normal will be on the center of this on the screen. And we call this plot a worm plot because it looks like a worm. But if anything happens, like here, our arousal will grow, and our avoidance also, we should get into extreme avoidance because we are fighting for our life. So the most important thing in our device is the fact that we are able to measure very precisely people emotions. We can measure how do they feel in very short time durations. For each of, let's say, quarter of a second, we have very precise measurement of 2 different kinds of emotions, of arousal, which is common, and emotions. And this is reliable, measurement and quite precise. We measure quite unusual reactions, so this is not positive or negative emotion. It's more animal-like approach avoid, but it's perfect for games, because when you play FPSs, it's like fighting for your life. So what does it give us, and what it has in common with games? Mostly, we are, thanks to it, we are able to measure flow. And what does it mean? Flow is, we can achieve flow when the difficulty of the game is similar to our abilities. So during the gameplay, our abilities change, so the game should change its difficulty. And if we keep ourselves in this perfect spot, we will achieve flow, so the nicest state that we can have in a game. But it's of course not that easy. If you try to research anything, you will find that it's always getting much harder. You cannot stay always on the straight line. You need pacing. So you need to change the difficulty dynamically because our brains are not working constantly on the same level. So that was one of the first things that we learned when we changed our indicators from online, that people have their own pacing. We don't even need to see them playing the game. It can be during the talking or anything else. We can see that some people, for example, let's make it easy. People which play strategy games, they have very long windows when they are concentrated, but then they have long windows when they are not concentrated and they cannot take any new information. But people which play FPS games, they have very fast pace. Their brains change their attention level quite fast. Their windows have few seconds, like 5 or 10 seconds. And if you check games like League of Legends, Quake, and things like that, you will see that when people fight, the fighting keeps people keep fighting at these lengths, and it's based on their on ideal performance of their brain, and you can measure it and see with our indicators. So, okay. Once more, so when we have pacing, it doesn't work only on this few second scale. We have scales on scales, and to be honest, after spending so much time on researching games, I'm starting to think about games like some fractal design or matroshkas, which where you have hidden states and everything. So we have slow game development. When you need to change pacing, you have the opening of the game, which should be attractive. Then you should have a little bit of time for somebody to get known to the game. Then once more something interesting, but you also need to keep interest in intervals of this 5 to 15 seconds, depending on the person. And it repeats on every time scale. Okay, so if we know that, and we can see that in our indicators, that we have so many scales and each of them means something important for the game design, what can we do with that? So we've spent some time talking with game designers and took what they taught us and built our very simplistic game. I hope that it will be simplistic. Of course, it didn't get that simplistic. I will repeat how to read the results that we will see in a moment in the video. So this plot, the worm plot, is when we are getting on the left, it means that we, the player, are in avoidance. Avoidance happens when we are not in control or something surprising is happening, or when we are on the right, we are in approach, so we are happy with, we are controlling the situation, or we are aiming on the enemy, and it's easier to see in FPSs. And the second thing, if we are high, it means that we are aroused, and when we are low, we are in apathy. And we don't want people to be in apathy in a game. Okay, and the second plot, the one here, it's showing only approach, avoid reaction, but we can see how it's changing in the time. It's used later for inferring with which monsters we wanted to play, which elements of the game were more important for us. And why do we have so many balls, let's say, in all of these plots? Because we have different time scales, which mean a little bit different things for us. Let's get to game. So we are the dot in the middle. And what's most important is that these monsters on the map, they are changing their behavior with the change of our own state. So this kind of monsters, when we are in approach reaction, they are getting faster. So if we feel that we are in control, they will get faster and harder to kill because they will get near to us. And if they get too fast, so that we will get scared, they will slow down because their speed is tied to our state. So you can see they after just a short time, they approach the balance between our emotion and level of difficulty, so that playing with them is one of the most pleasant things, because they are always they are pushing you to your limits, but they keep the play pleasant, because they don't get too hard, they don't get too easy, they always push you to be very active. And we hope, at least, that this way we can show the difference in performance of our indicators. I've spent 12 years working on this indicator and its precision, and I believe this is the only situation where you can see so reliably your emotions, and you can feel them just in few seconds when you meet, when you play this game. Okay, so what we are providing, providing for people which want to design or play games, the feeling of immersion, because your player can change, is changing their performance, and by performance I mean how many bullets he shoots, for example, or how strong his magic is, based on your state. So this is the smallest possible scale, and it's showing that if I'm feeling aroused at the moment and in approach, my shoots will be stronger. But the second thing is live adjustment of behavior of monsters and other things in the game, like you could see a moment before. But there's more. We are currently having a larger project working on using clip and guns to find the what styles of game, which looks of it people like, with which monsters do they like to play, because they have many different behaviors, and how to change game state based on somebody's preferences. And on the last scale, and this is mostly for larger game designers, they are getting information about what did we like in games, so what should they do more in it, what should they add in the game. And that will be very short. You said that I have 20 minutes, I tried my best to be short.
That's a great presentation. Thanks, Maciej. It's a lot of elements to unpack, but I first would like to, pick up on some of the questions from the audience that were really interesting, and I'd like to go through them.
Okay.
So first, I have a question for you. So if you have a game and then you're measuring arousal and apathy on one axis and avoidance and approach on the other, I guess. Yeah. What is your shortest reaction time?
Oh, you can by the movement of this worm, you can see all the scales that we are measuring. So really, we have 60 hertz of information, but it's not very useful in case of games to use the fastest scale. It is precise enough that you could use it, but it's quite hard to build. I've spent quite a lot of time building algorithms for this game. I hoped that it will be easy, but no, to have a game where behavior of the game changes, but depending on your state, it's quite hard. That's why we built our own game to show people which algorithms they can use and how to use this information. So it's much better to use slower scales, because it's much easier, not for the game, but it's much easier for game designers to use them. And the scale that people like and understand, and it's easier for them to use, is scale of about quarter or 300 milliseconds, quarter of a second or 300 milliseconds. And at this level, people slowly start to understand what this indicator means.
It's super fast, Maciej. do you also have an indication on how easy it is to control your own emotions? In fact, this relates to Itamar's question.
Hard.
How do you calibrate emotions, right?
We don't calibrate emotions. Our indicator is based on a patent that we have, and we have this patent for USA and Europe. And the fact that we have patent means that the approach that we have for EEG is unique enough that you cannot find it anywhere in scientific papers. And I've watched this space for quite a long time. So if you could repeat the question, because I've lost the track.
Yeah, I think one of the audience question from Itamar is how to calibrate emotions. I think that starts from the assumption that you can control with your own will the movements of these plots that we've seen, but probably you have some comments on that, right?
Yeah, for starters, we don't calibrate emotions. We found reaction which is repeatable between people. We don't use any machine learning in any place. It's only statistic and signal analysis. So our indicators work for everybody. I hope for everybody, at least for all the 500 people that we've tested. And they are as precise in each person. They just need some time to check what are your usual levels of emotions. So it's
you
better
tested 500 people.
Yes.
500 people. It's a very reliable measure to me. If you have it consistently for 500 people.
Yes, and but the nicest tests are when we give people the live indicator. We just leave them with it, and the things that you can see are you don't want to show all of your emotions to people, because when you start to be able to read them, you could see when you are concentrating on what you are saying, or when somebody is saying something. There are many ethical concerns. When you get to this precision, it starts to be problematic. So we take quite a lot of care of that.
Understood. And there is a bit of a question about visualization of your graphs. I think the label on the right side, opposite to avoidance, is approach, right?
Yeah, I'm sorry. It's it's violet, and that's approach.
So you were telling me in a private conversation that this axis that you decided to have to control brain states, they derive from a theory of inhibition and activation, which is a behavioral theory of system theory. And then
yes, thank you.
Yeah, can you comment on that?
Yeah, I'm really thankful for your question. Yes, our research is based on 40 years of research in psychology and around 35 in neuroscience. The thing that we made is we didn't find these reactions. They were always, let's say, there. And avoid approach is one of the oldest ones, and you could read it in James from 100 years ago. The thing that we did is just to improve the performance. So, like I said, my specialty is improvement of signal quality. So we didn't do nearly anything else than drastically improving the quality of the EEG signal for particular type of methods. And that's why we have such a high precision. We are using let's say, usual science and findings. We had to only change on which theory we are based, because funny fact, people in neuroscience lost half of the theory about approach avoid, but you can find it in older psychological papers. Mm-hmm. And I thought for quite a long time that I'm making some mistakes in interpretation and something is not working for an indicator, but later we found that in original theories which were made on mouse research and similar, they spoke about the same reactions that we are findings. So there's surprise, for example, or concentration.
So this theory is called BIS-BAS from Greece,
yes,
I believe.
I'm trying to not use this name because people don't remember it. It's BIS. It's behavioral inhibition system. That's avoidance, and BAS. It's behavioral approach system.
Understood. And who is the main author from the historical psychology systems?
So for psychology, it will be great, but you can find people speaking about approach avoid from Freud and James until now. And in neuroscience, the most important person would be Davidson and his 1997 paper.
Thanks for the references. And I believe in the other axis, in the vertical one, we have a comment from Richard. Is looking at some science of behavior. Probably we can pick it up later. So my question was about the vertical axis of arousal apathy. So I guess this is measuring some oscillatory ratio between theta, alpha, gamma, beta.
No. I won't say what it's using exactly. I'm sorry. But it's byproduct of BIS-BAS measurement. Because BIS-BAS measurement is made as a difference between left and right prefrontal cortex activity. I just checked one day if not the difference, but sum of their activity means something, and it perfectly correlates with people arousal. And that's taken from absolutely nowhere. We just tested it on hundreds of people, and it works. That's a new finding, let's say. I might have said the same about flow measurement. It was not our idea that we can measure flow. I've made game research for quite some time, and game designers said to us that the thing that we are measuring is a flow. So it was not our idea, but our customers, because we used in past life to make game testing.
So do you have a kind of standard validation paradigm or something where you say, this is a game where I know right at this point in time the person is doing approach, and then you take your EEG signal and say, yes, when this says this, this says this.
Yeah.
90% classification accuracy.
We don't do that with games, as this is a new development for us. But we have a paradigm that gives us this information, and it's based on dynamical social psychology. Because let's say normal psychology or neuroscience, it's quite hard to find dynamical patterns. And my extra specialty when I was studying was dynamical social psychology, which has a few let's say, special types of experiments which allow you to measure dynamical changes in emotions. And yes, we made tests on 70 people to check that, but we didn't publish it, and we will not publish it because that's our company secret.
I understand that, and that's part of one of the faceted aspects of synergy between academia and industry. And sometimes it doesn't have to be a synergy. Sometimes, you have your own IP, and that's part of what comes out of academia from previous research labs that you adopt in industry, and that's perfectly fine. I wanted to connect to this point with one of the questions from Alfredo, that is asking if this avoidance effects or these axis variables that you have are cognitive processes or they are autonomic processes. Are these effects that you measure cognitive or autonomic from the autonomic system?
I'm not sure if I understood the question. They're
in terms of what you're measuring. You have a measurement of flow.
Yeah, it's completely based on prefrontal cortex activity. So I'm not sure if that answers the question.
I think that's an answer. It's a cognitive process.
Yeah.
John, you had a question. I believe you want to ask your question, John.
Yeah, sure. Well, so I think we touched on a few of them, but I still have some questions. Like I find this 2D space, this trajectories in this 2D manifold, like super interesting.
Yes.
And it's so that literature you're talking about, this like dynamic social psychology, is that coming from the dynamical systems in cognitive psychology, kind of Thaler, who's the guy, Van Gelder kind of stuff?
It's very narrow discipline that's based on like 50 people in the world, based in Florida and in Poland. So
Florida,
it's
right?
very narrow.
Okay. Like Kelso
discipline.
and Co.
You can check Valacher and Novak if you want to read more about it. It's very interesting. Now we are getting back to complex systems, and we can see more and more of them in neuroscience. But when I started, it was not that common. And this perspective is really helpful to make experiments. So even statistically, it's very helpful.
If you look at the kind of abstracts list or the keywords at Society for Neuroscience or related things, then manifolds, low-dimensional manifolds, neural activity operating on low-dimensional manifold, all the rage. That is like one of the hottest topics at the moment, and that's exactly what you're doing here. You found your manifold from your projection, which you're keeping to yourself, but fair enough, you have your projection. And then you're seeing interesting behavior, but it's really cool that this is something that there's a lot of interest in general, in behavioral stuff, in cognitive spaces, in brain spaces, and it makes a lot of sense for like scientific understanding. It makes sense for how the mind works. Like we're not moving through million-dimensional spaces. Like we're simple creatures.
I'm trying to not speak too much about science, but if you want to really use this this is really a manifold, because this space doesn't behave like 2D space, it's 3D, and you will need to read about catastrophe theory, because when your arousal is high, your emotions mean something a little bit different. Yes, and then on this worm plot, you have like 6 different time scales at once. There are more dimensions that I want to speak about. Yeah. I'm quite happy if somebody has time, but maybe not now.
It's a great explanation as a bird eye view, as an appetizer, to entice the audience. But everybody would like to know more, and then definitely
we have more.
See your use cases, right? And think about what other applications you can cover with that. And on this account,
the nicest, I will end with that maybe. The nicest thing is that when you play a game like that, this is active biofeedback. So by choosing with which type of monsters you play, you're training different skills. It's really, really hard to control your own emotion or arousal, but if it's made as a game, it's much easier. You can play for much longer, and now we are trying to test what are the long-term consequences of playing such a game. And it's not an easy question. It can be very beneficial, but if we make some mistake, it could be very dangerous.
So Maciej, I have a technical question. So can you tell us more about the EEG that you're using? You say that you measure prefrontal cortex, but your EEG is on the back. Can you tell us more about the EEG that is being used?
We have 2 electrodes. One is here, and second one is above the ear. So it's F3 and T7, let's say. And similarly on the second side. So we don't have anything at the back, and we are trying to keep the forehead clean from anything.
So the headset is not on the forehead?
No, it's on the
It's on the forehead.
You have nothing on the forehead. Just
okay. Here. Understood.
It's like if you would put your headphones back.
And what's your impedance?
Impedance. Not sure, sorry.
You're measuring EEG scalp waves, right?
Mm-hmm. Yeah.
What's the quality of your signal?
We are testing it. These are dry electrodes, so that's why we don't have the device on the market now, because we are fighting with the device to achieve the best possible impedance, and it's really hard. Our heads are shaped in such a weird way. I didn't know that before I built the device, but to fight with the impedance, because we specialize in signal quality, but the thing that we are trying to do is to achieve as high frequency for the device to be able to repair the signal even if we get low impedance. And as long as electrode is really touching the head and you're not completely dirty, let's say, that's enough. With 2 kilohertz of the signal, there is enough of statistical power to achieve that. And we have in company Adrian, which is a specialist in speed of algorithms, and he can improve any algorithm to work faster. So we have extremely fast algorithms for data cleaning.
So you're sampling at 2 kilohertz, you said?
Yeah.
And beaming it wirelessly via Bluetooth?
Yeah, and we are sending 4 channels, 2 kilohertz by Bluetooth.
Interesting. So what's your, there is another question from the audience that is, how long would a person be able to game using this BCI before being cognitively fatigued? And, how long can they game?
Yeah, this is the most pleasant thing, because you don't try to control. I don't believe that we'll be able to control games by EEGs soon, because the precision of BCI interfaces from movement is just so much lower than the precision of a single finger that we are not trying to do that. This is a passive BCI, so because we have no effort, we can play as long as the battery gives you.
Understood. So you're measuring, this approach and avoidance, and as such, you're not controlling anything with your free will.
Yeah. So you don't
it's provided to the gamer as a kind of report on their
extra input. Yes.
Yeah.
Yeah. So it's informing game what it should do to be nicer for the player. When he wants a break and when he wants to something harder.
That's super interesting. I have another question from the audience, Maciej. First of all, I attach something to the question from Richard, and he asks how much training data in hours has been collected so far. And I'd like to specify Richard's question in terms of, are you using a model that you're training?
No, we have no machine learning whatsoever. That's just science and signal processing. I like to read machine learning papers, and I'm okay with building models, but I don't use them. If I can understand something, we are trying to use only things that we can completely understand. And if you will read my Twitter, you will see why.
Understood. So you're using real-time online computations on the fly.
Yeah.
Very interesting.
Everything is science-based, and that's 12 years of lots of research in basic signal analysis.
That's very interesting. We do have a question from Shatushika that asks, what are the social aspects that you have considered with the possibility of training yourself to control your emotions, right? In this systematic way through a game. I guess that means if you play with these warm representations and you have this feedback, can you train yourself implicitly to do something? Can you learn something about yourself?
Yes, I used to not be too emotional a person, let's say. I was not born with a lot of emotions, but last 12 years of watching how people feel in different moments, depending on who they are, where they are, and things like that, I've learned a ton of stuff about how others feel and how I feel. And I'm constantly using that everywhere. It's a completely new thing to see emotions on the scale on which you can see it on this plot, because you can catch your emotion or somebody's emotions even when they are speaking, and tie it to a part of a sentence, to a reaction to somebody speaking. And what you've made really lots of different types of tests on different data sets to understand. And it took us nearly 6 years to really understand what we are measuring. It sounds nice. Okay, so we have the precise indicator of some process, and it has some theory, but the psychological and neuroscience theory for emotions is based on a single second watching of pictures or some long movies or something like that. There's no theory about how do you feel in a quarter of a second when the loot is jumping out of the monster or something like that. We had to create a ton of new wisdom about how emotions work, and try to find it in different places.
Wow.
And it was really hard. So you can instantly nearly learn, because when you see your own emotions, you get an apparatus to name your own states. And you get quite a lot of wisdom, not because you have new words and you have no new ways of imagining what's your state and why it's happening like that.
That's really informative, Maciej. And then I think this is really inspiring work that you're doing. And one natural question that comes out of that is a practical one, less philosophical about our emotions, is can you use this technique also to calculate approach avoidance and arousal drowsiness while driving a car?
Yes.
Hopefully not
yes,
too much
you can.
approach
You can
in driving.
you can see how
Not
the
too much approach
performance.
behavior.
Yeah. And you can see when somebody is able to concentrate and when not. And the funniest thing that we will not repeat evermore is that we've tested the new version of software. We had a company meeting, and we are discussing some company business. But because I was showing the new version of the software, one of us stayed in a headband during the talks, and I was able to. Me and the guy was able to see his indicators live. We'll never ever do that again.
Wow.
Because you can see to whom he's listening and what emotions does he feel at that moment when he stops paying attention, things like that. And you can see very small differences, and it's not something that you want to show to people.
That's actually quite groundbreaking. And somebody from the audience, Alfredo in specific, suggests this could be used as a methodology for dating apps.
We are trying to keep ourselves from, for use cases like that, we keep ourselves far away from any military or anything like that. So we don't want to go there. It's too personal to give away.
Military and dating, they're quite close to each other.
Yeah, I hope, as John says, I hope you manage to keep your technology tied to your chest. Not that it's going to be misused, but this is groundbreaking. And then I think a lot of work went into algorithms development, right?
Yes. Yes. Yes.
And we don't want to, spoil the secret sauce that you explained to us. We leave it to capable hands, to you and your team. And then we have been flabbergasted by your presentation, and it's really impressive what you present. And then I hope that you also get in touch with our next guest, Hanna Shanjay, that are also developing applications to be able to control secondary automobile controls for people that are tetraplegic or paraplegic, so that they can react to the environments better, and also control with the free will. But also maybe also you can speak with them about that if you think that this is part of your mission and vision.
Okay.
I think that was an amazing presentation, and
Yeah, thanks a lot,
Maciej.
Maciej.
Yeah, what
Thank
do you
you very
think,
much.
John? Shall we have you in the background to have a final conversation and take questions? But if you want to go, we understand. But I like you to listen in at least, and then you will find the recordings online on YouTube right after this meeting. And we really appreciate your contribution and your interesting expose tonight. It was really inspiring.
Thank you very much. I will try to keep myself alive.
No worries. We understand if you want to go.
Hey, Maciej, if
Okay.
you could drop any references to this like early psychology emotion literature in the chat, that would be super interesting. The kind of early work you were mentioning.
Okay. I will drop them in the chat in a moment.
Great.
For sure, and feel free to answer questions from Richard also in the text chat. Thanks, Maciej. I'm gonna have you out of the screen for a second and invite the other guests. Thanks. This was extremely interesting. I'd like to know what Hanna and Shanjay think about it, because they might find some useful synergy there. So I'd like to invite.
I read a little bit about the company. I didn't know about this manifold, this 2D worm plot thing. It's a real interesting approach.
Yeah. Hi, Hanna. Hi, Shanjay.
Hey, Cris.
Hello. Can you hear me?
Hi, guys.
Yes, we can hear you very well.
Hey, John.
We're happy to have you tonight.
Happy to be here.
So where are you guys calling from?
Hamilton and
Oshawa.
Yeah.
Yeah, so it's Ontario, Great Toronto Area, and Hamilton. So we are happy to have you here tonight and to tell us something about Axcessiom and your vision and mission. And also personally, I have to ask at some point during your expose what you think about Maciej's presentation, because it was really quite impressive.
It was really impressive. Actually, during the presentation, Shanjay and I were just talking about how complex it was. So, in terms of what we think it's quite complex, and it's just amazing how much, Maciej, if you're still listening, how much work you've put into it, because it really shows. It's quite, it's stellar, spectacular.
I agree with what Hanna says, and I think this technology can be applied to so many different things. Like it's really quite amazing. What can be done with that technology. So great job, Maciej.
Yeah, and on this line of thinking, also we appreciate the work at Axcessiom that you're going to present as COO and CEO, right, Hanna and Shanjay. And then this is really the power of technologies to adapt to rapid changing world, and to find algorithms and techniques like facial recognition that are able to gauge signals from our body and then transform them in some actionable controls. And as partly what Maciej is doing, but definitely what you are doing at Axcessiom. Would you like to present the mission and vision and tell us a bit about yourselves?
Sure, yeah. So I guess should I just present? Like, should I just do the presentation first, talk about what we're working on?
Or sure, please go ahead.
Or maybe, let's introduce ourselves first, and then we'll present. So my name is Shanjay, and I am actually a student at the moment. I'm doing software engineering undergraduate program at Ontario Tech University, and I should be graduating next year, so I'm looking forward to that.
Great.
Yeah, and I created this startup, I think 3 years ago now. Yeah, just over 3 years ago. And yeah, we've made some really good progress in the last year, so you guys will get to hear about it all real soon.
Sounds good.
Yeah, I met Shanjay about a year after he started the idea, and we met at a tech conference, Collision in Toronto. For the first year it was held, and we met at one of the after conference hangouts. He knew I was kind of interested in human behavior. I was kind of dabbling in some very minor toy problems with computer vision. So I'm also still in school, studying human cognition and perception. So we kind of binded forces and have been working on it ever since. It's been a blast.
It's amazing.
I got to jump in and ask about the collision conference then, because I've seen this advertised. I've seen the roster, and I kind of had this voice in my head a few times, like, John, get down to this thing. It's just down the road. So like, what's the atmosphere there? Like, clearly
it's
brought
awesome.
you two together.
The in-person conference is unparalleled with what, I don't know. I didn't go to the virtual one. I'm sure it was awesome, but just walking into a room, there's like 40,000 people all just like, talking about what they love and the work they do and networking. That was great. But then you have these like mini after parties, like whiskey lounges or like restaurants where you just meet random people from the conference and you can strike up a conversation in a relaxed state, and just keep sharing your interests. It was fun. Some big players there, but also like local players too. It was nice to see that exposure in Toronto.
Yeah, and Cris, I don't know if you remember this, but you were actually there. I just realized that now. We were all three of us were there on the day.
I guess I barely remember that. Yes.
Yeah, that was a good night. That was
very good night. So
yeah.
I love the atmosphere, and also I remember that I've been there. I and Sanjay worked together for a brief period of time at Cognition, and so I'm also honored to have you here as a former colleague. And that experience, it's very much in my mind, and I cherish that memory because it was a great opportunity not only to party together and then meet new people, but also to exchange ideas and opinion with leaders in the field, also from outside, like you say, Hanna.
Yeah, and full disclosure, that was an open bar night, and I was completely hammered, and so was Hanna. And
That's how you develop. We develop good ideas, right?
Yeah, honestly, when you're relaxed, info just flows.
Yeah, I'm just looking at the chat. Look, I see Tom Ladd is here. He was also with us there that night. Hey, Tom.
That's great.
It's a good memory. We hope that we will be able to have it live again, Collision 2022 or maybe 23.
Yeah, I hope so. I'm definitely going to be there.
Yeah, Axcessiom maybe would present this time.
Yeah. Okay, so I guess I'll get into the presentation then and talk about what we're working on. So I will share my screen. Strange. For some reason, it's not pulling up my PowerPoint window. Should I try refreshing this page and coming back into it, Cris?
Yeah, you can try refreshing. I'm gonna kick a couple of us out because we have a limit of 6 people.
Okay.
And maybe John, I can reinvite you later on when Shanjay and Hanna are ready and finished.
Sure.
Yeah, I'm gonna refresh. I'll be right back.
It's okay, Sanjay. You can try and share now. And or Hanna, do you want to have the presentation on?
Oh, he's back on.
All right, let me give this a try.
Sanjay has the most recent slides because actually we presented at Lions Lair earlier this afternoon. So those are the freshest slides.
Understood.
He cuts them out too because we just kind of.
This is really strange. I can't.
You know what? I think you emailed them to me. I can try to pull them up.
I haven't emailed you the most recent copy, Hanna. Let me just send that to you right now.
That's okay. We can just go over like that. It's quite strange. Sorry, everyone.
It's okay. Take your time.
Okay, I've got them.
Yeah, if you want to just pull up your email real quick, it's sent. Oh, there you go. I see it now. Okay, that's weird.
Okay. Okay.
Okay, I'll just share my and share audio. Can you guys see that?
Yep.
Okay. All right, so I guess I'll start presenting. So hello again, my name is Shanjay Kailayanathan, and I am the founder and CEO of Axcessiom Technologies. Now you probably can't tell on camera, but I'm actually in a wheelchair. And I'm in a wheelchair because I got into a car accident many years ago and it left me paralyzed from my chest down. So the product I'll be talking to you today, it actually stems from a problem that myself and many other people with disabilities face on a daily basis because of our disabilities. So what's the problem? So imagine you're driving a vehicle, except your hands are glued to the steering wheel. Now try turning on the turn signals. Probably not going to be able to do that, right? This is a sad reality for many drivers with disabilities. And the reason for this is because drivers with disabilities use hand controls. And with hand controls, one hand typically controls gas and brakes, while the other hand controls the steering. So if you can imagine, while driving, both hands are in use, which makes it hard, sometimes impossible, to control secondary vehicle functions such as turn signals, lights, wipers, etc. So how do we solve this problem? At Axcessiom, we created FACEIT, which is our advanced driver assistance system. Our system consists of a hardware platform coupled with artificial intelligence to ensure that the driver has the safest and most effective driving experience. Specifically, we use facial gesture recognition to control the secondary functions of the vehicle. So for example, if you wink your right eye for 2 seconds, your right turn signal will come on. It's pretty straightforward. There's different facial gestures that can do different functions. It's completely up to the user. They can program what they'd like. So, if they want to stick out their tongue to activate the wipers, they can do that. It's just a quick overview of what we're doing. It's nothing too technical. I'm not going to get into any technical stuff. Here's some FAQs. I'll just leave this up on here. But I guess if anyone has any questions for us in the meantime, we can kind of get into that.
Yeah, you can go ahead and give us an overview of your typical Q&A from audience or users, or what you face during your daily routine.
Sure. Maybe Hanna, do you want to?
Yeah. Okay. So one of the biggest questions is question number 2. Why not voice rec? So one of our competitors that's, I wouldn't say dominating, it's because it's not their primary product, but they basically they have a voice recognition system in cars. So you can say left to turn on your left turn signal, for instance, right? But good luck if you have an accent. Good luck if you have kids in the car, if you have your windows open, your radio, if you want to talk to your friend, none of that works. Even if it's sometimes quiet. I don't know if anybody here in this audience has ever used Alexa or Google Home when it's completely quiet, you're being completely articulate, and then you just get angry because it the command doesn't go through. So that's a common issue that we face, or that we've heard our user base face on a daily basis. They buy the thing and then they completely regret it. But then it's too late at that point because they've went through all that testing, all that, they get a prescription for this tech, right? So that's weeks and weeks of being tested. And then it's sunk cost. By that point, they're whatever. It's not a big deal. I'll get around it by modifying my voice. And there's a learning curve too. But with our tech, it's cool because, even if you have an accent, even if you've had something like a stroke, right? Our stuff is facial recognition. But even if you've had something like a stroke, that's okay, because our algorithm takes a base of your face, trains it on your own data, and then applies our external algorithms to then, test on your face. And it's accurate, it works, and it's not a big deal. And I mean, a great thing is that, you're driving and we're trying to get rid of the hands, having to push a button to turn on a windshield wiper. We like the idea of the face because it's not being used. You're not really, worst case scenario is like for us, which is kind of another issue or a question we get is, okay, let's say you're laughing and your friend is right beside you because your friend just told a joke and you're laughing. Okay, how does our system actually not register that as a false positive? So that's kind of still at the crux of our testing, but we've gotten ways to kind of get around that. And that's basically just kind of comparing, let's say, something like a regular laugh that maybe lasts for a short time to, you know, a really like open mouth, like kind of weird face. Like, so we're trying to be as natural as possible, but we also have to make the distinction between natural and artificial to like not get that false positive rate to skyrocket.
Understood. And can you tell us more about your, you know, business and how do you exactly, you know, deliver the features of your product in a way that you were starting explaining it? So how do you train, you know, potential car drivers to use your product, and how do you not stumble upon false positives? Is there a training phase that they have to go through?
Yeah, and this is an amazing question for us right now because we're planning our beta testing right now. So we've done a lot of alpha testing and it's great, but what happens when it's like in the real world and they have to go and get this tech? So the main way that somebody goes and gets this tech is they go to what is called a certified driver rehab specialist. Think of it as like an occupational therapist, but for drivers with disabilities. So they go to the center, they get assessed. Let's say the assessment center says, you know what, the facial rec system will be best for you to use. We're going to try and set you up with that. So when they get in front of the camera, the system, and they have to go through a calibration period of sorts. So, okay, show me a smile, show me a wink, show me a brow furrow, show me your tongue out, show me an open mouth smile, all of those. And then it'll probably take a day. Why? We need to make sure we get training data in lighting, like very bright conditions and not as bright conditions, dark conditions and then cloudy conditions and then bright conditions. So probably would take a day, maybe spread out through a week, different times of day, let's say an hour a piece. We're trying to get that calibration period down, but that's what the beta testing will help, is just to show how much people can take in terms of actually going through like this period of training. And then so that data is input, let's say, and they can go off. You know, the more data they give us, the better, of course. But we don't need a lot of data to start to make this work because we already have data from other people, from like we have external data that helps minimize that onboarding, you know. I hope that answered some of your question.
Yeah, thanks for this. And we have questions also from John. Hi, John.
Hey, thanks for having me back. Great presentation. So I might be just in the dark, but what percentage of cars like on the market are compatible with a third-party control system? You know, what and just a little bit more on the area. Like, what is the process of like developing technological solutions that are like giving those instructions? Like, is there a straightforward API for all of the cars you need, or like is that quite custom, so on and so forth? Could you elaborate a bit on those things?
So yeah, sure. So I can talk about on the market side, and then I'll let Hanna answer the second part of that question. So in North America, there's actually 12 million drivers with mobility-related disabilities, and 800,000 of those drivers have an adapted vehicle. So an adapted vehicle, for example, can be something like a wheelchair-accessible van that has a ramp, right, that someone in a wheelchair can drive into. I personally have a vehicle like that. So, you know, there's 800,000 people in North America that have an adapted vehicle. Now, the second part of your question.
Oh, it's like the API. Okay, so like for instance, we just reverse engineered a 2018 Dodge Caravan. So like for all intents and purposes, it's like, I don't know, when did CAN bus change? Like for the Dodge, like, I don't know, 2012. So all Dodge Caravans after 2012, we can easily reverse engineer. All you need is a wiring diagram for any new vehicle. And then we had to buy like some pretty expensive hardware from Vector to like, because that wiring diagram doesn't give you everything. So you still need like, 1 or 2 months of reverse engineering the thing. So it would probably take, like, now that we know what we know, if you were to give us like a Toyota Sienna, provided that the wiring diagram would give us enough information, then we could program that or reverse engineer in maybe 3 weeks. But who's to say that OEMs like in the future aren't going to encrypt that data further, making that process harder? Because it's not encouraged to reverse engineer your car. Once you do that, it's not like it's fine for what we're doing because we're not doing the primary controls. We've contacted MTO Ministry of Transportation, and they're like, yeah, you're good to go. You're not like messing with the primary controls. It's fine. But still, OEMs don't like when you do it. So
so that's interesting. So it's the wire. You say the wiring diagram. So there's like, you actually have, I guess, like hardware interfaces at a bunch of locations throughout the vehicle. Is that right?
Yes.
I was thinking maybe there was more of a, software kind of interface.
It's a bit of both. So controller area network of the car, the CAN bus of the car. It's like the brain of the car. There's like a main brain, and then there are many other like neurons and like neuronal bundles that connect to that main brain, and then those like bundles connect to other like actual let's say like efferent neurons. Like, I'm trying to relate it here as well as I could.
Effectors.
Effectors, right? So we're targeting the main brain, and we're trying to see how we can use two wires to control it to the main brain, to the CAN bus, so that we can access everything else, as opposed to current solutions which target the effectors, like the electronic control units directly. So it like messes up the entire architecture of the car for the user, depreciates the car's value. It sucks.
So to add to what Hanna said, our competitors, what they do is they make a lot of splices into the vehicle's wiring, and let's just say they want to be able to control windows, they splice directly into the windows and control it manually. For us, almost everything is done through CAN bus, which is 2 wires, right? So we just send a signal into two wires in this car, and we can control almost everything that we need to.
Right.
So is there a protocol that you follow that is made available with permissions as well from the automotive industry?
Yeah, the CAN protocol, controller area network.
Understood.
Yeah.
So is there a license that you have to purchase to be able to send and receive commands?
No.
Well, I mean, in a sense, like the vector canoe stuff, right? It's this piece of hardware and software that allows us to access that CAN bus. But it's not something that the car manufacturer gives you. It's just a third-party company that has made this piece of device that allows you to better understand the car's language. But you still have to find like the wiring diagram. You still have to understand what the architecture of like the computer looks like, because you can't just like guess, because you can actually like screw something up.
So you have things that are probably labeled with like uninformative numbers, I'm guessing, like action 5391.
Exactly.
And then you need to figure out what that does.
Exactly. Yeah, exactly.
Right.
And that's what that tool does for us, right? It allows us to see what values are changing when we do certain things in the vehicle.
It gives you like a course dictionary.
Right.
Understood. And that's one question that is also related to, I guess, the business model that you're pursuing, which is if you are being approached directly by car manufacturers, because Richard says that this seems like an interesting feature that could be wanted by vehicle or car companies.
Yeah, that's definitely on our radar. It's like one of our goals, I would say, is to be able to have OEM reach out and say, hey, we'd love this in our new accessible vehicle and would love to give this as an add-on to our customers. Bulk purchase order.
Yeah.
I mean, they would license. Yeah.
Yeah, we've actually been in touch with a company that's developing a new all-electric vehicle, SUV. And they actually reached out to us to ask us about some, accessibility related questions and possibly working with them to add our technology as an OEM feature. So that was pretty exciting.
Do you think this process that you have to go through to like look up the wiring diagram and figure out what the commands are, is this something that will get phased out over time a little bit with just some modernization of the interfaces and maybe of standards? Like, so maybe there'll be a menu with English words or something at some point, that rather than you having to do that kind of decoding on a case-by-case basis? Or do you think it's going to stay put for quite a while yet?
I think that's going to be the case for a while, just because that's not really normally public knowledge on where the CAN bus networks are in a vehicle. That's something that you have to look into or kind of speak to the engineers of the dealerships about. So yeah, it's gonna be a little bit of work figuring out where the wiring is, but it's not too big of a deal, I don't think, anymore. I think the hardest part was trying to figure out how to actually reverse engineer the vehicle. But now that we've done it with one vehicle, it's pretty straightforward with the rest.
Understood. And then for the public, OEM means original equipment manufacturer, and is a way of making business of companies that don't want to figure with their own brand on inside a car, but they provide their hardware as Toyota car reseller, so that they can embed it in their car and resell it as a whole. And it's great that you are pursuing this kind of business model. But the question that I had in mind before when I was listening to your presentation is if you could tell us a little bit more about details of how you develop the IP for facial recognition in terms of technical details. So what kind of mimics are you able to capture? You say that you can wink left or right, or you can stick out the tongue. How is this technology developed? Is it based on machine learning algorithms? Do you purchase? Do you develop the technology?
Yeah, so we went through a few models and circled back to some. We started with convolutional neural networks using a YOLO network. So that was okay. It was accurate, but it was so slow. And you need big computers to be able to get the speed you want. So we scrapped that. And this, by the way, we scour literature and just try to recreate what people have done, but in our context. And thankfully, in the machine learning community, there's a lot of free resources out there. So it's a matter of looking at what's available and then modifying the hyperparameters or the architectures in some way to suit our goals. Then we did a non-machine learning approach, like eigenvectors. So basically just straight up just brute force calculating differences in pixel values, calculating the means of certain clusters. And that was good, but good luck if you're in a dark room, just, it doesn't work. And then we went back to a machine learning model. Now we're using this is the one we started with. This is the one that we created our MVP with. But I created that MVP, but then I'm not a machine learning scientist. So we hired a machine learning scientist, and he's actually implementing the same model, but it's a hard cascade model. So it's like you basically first have to annotate landmarks on a person's face. So like points, you know, that demarcate like the mouth, the eyebrows, whatever, calculating the distances between them. Those are based on pixel values as well. But anyway, so that's been really fast. He got that model and tweaked it, and actually added a few things that we didn't have previously with it. So that's been great. He actually just sent us a summary of the false positive rate, and so the hit versus miss report, and it was fantastic. We were so happy. It just worked really well in all lighting conditions, and it's very fast, which is great because, you know, let's say you're merging and you want to turn on your turn signal, you're on a highway traveling at, I don't know, 90, 100 on the ramp. You know, it should be fast. So, and it is that fast. It's like real time. So yeah, we're back to the machine learning model.
And I wanted to ask, related to this. So can you give us some examples in terms of the facial gestures? Like what is actually happening? I'm sitting and driving, like smile, stick my tongue out, look left and right.
Yeah. So like,
can I actually play that video, Hanna? I think.
Actually, yeah. Why not? That would probably be better.
I think this is a good time to share this video. Can everyone see this right here?
Sure.
Okay. Let me hit play. I hope the sound works. If you guys don't hear any sound, let me know.
First, the driver will close and hold one eye to turn on the turn signal. Notice the camera at the top of the windshield inside the vehicle and pay attention to the turn signals outside as he does the gesture. Next, the driver is going to activate the wipers with a big smile and one eye closed. Finally, he will activate his turn signals by closing one eye.
So this was actually a prototype that we just finished up about a month and a half ago, and this was the first version that we actually tested inside of a vehicle, and this was not as fast as we liked. So since then, Paulo, the guy driving, he's our engineer that's working on this facial gesture recognition stuff. He actually created a much faster version, which is the one that Hanna was just talking about. So, you know, Hanna, if you want to add more to that.
Yeah, the YOLO network was slower than this video on screen if it lagged for anyone else. So yeah, honestly, basically, like, let's say, okay, my eye is open right now, and the resting state of my face would be detected with the landmarks, right? With the landmark detection way. So let's say my entire eye is outlined with these dots, with these landmarks. And then as you close your eye, the distance between the points on my upper eyelid and my bottom eyelid is lessened. And that's identified as an eye closure. So it's about the distances between the points on your eyes. Same with a mouth open, hung out. The landmarks change, the points change, and therefore the distances between the different points change as well. That's the gist of a hard cascade model. Anyone can implement it, but then it's a matter of actually fine-tuning it to serve your goals. Because, you know, just because it works doesn't mean that it can work fast. Yeah.
Understood.
And are the instructions kind of complex sequences, or is it just close your eyes once?
They could be, yeah. So we have maybe like 5 or 6 standalone facial expressions, facial gestures, but then you can Morse code it. So for instance, if you want to turn on your radio, something that doesn't require a lot of like quick reaction time, you can do, you know, smile and then a wink or something.
Right.
And do you have a hardware mounted on the car that does the operations on a CPU, or do you piggyback on the car's CPU?
We have our own CPU. Yeah. Yeah.
Can you tell us more about that?
Yeah, we've gone through a few hardware components. We started with a Jetson Nano. Raspberry Pi was actually the first thing we've ever used. A great little nifty computer, just not strong enough. We moved up to a bit of a stronger NVIDIA CPU, but now I think we have to actually make our own because we want it to be even faster. So yeah, if anyone out here actually knows or has any help for making a custom CPU, like, please let us know, because that's kind of, we're always probably going to be improving that component. Just very expensive.
Yeah, John, did anybody come to mind?
I know some people who worked with the Jetsons, but it sounds like you've moved on.
Actually, Hanna, I think the latest version, it's not too processor intensive.
It'll be very good for beta testing, and it'll be fine. Yeah.
Yeah, I know the current version that Paul has worked on is actually it's working quite good on the Jetson. Like, it's not you know, it's not like we don't have enough. I think it should be okay for now. Yeah.
This is most intensively computationally demanding because it's video streams.
Yeah, exactly.
So it's a lot of data.
And we're trying to get high frame rates also, right? Just because we're trying to recognize gestures quickly. So I think that, yeah, it is a lot of computation for sure.
So there is a lot of IP. Yeah, go ahead.
You need like what would be the kind of ballpark time that you need a classification in? Is it kind of 50 milliseconds or 200 milliseconds?
15 FPS is pretty good. Pretty good
15.
for 15. Yeah, not that, you don't need it that fast.
But when do you need the classification by? Like, what's say the time to the effector action, the light turning on or something from the facial gesture?
Oh, the fastest we would need is probably like 120 milliseconds.
Yeah, that's like really good. I think anything within a second is good, and we already have it now within a second with the new yeah.
Any significant latencies from the actual the cab bus thing?
Yeah,
or is it mainly on your side the time?
Yeah, so it seems like right now it's mainly on the processing side, like the image processing. That's what takes the longest, right? Classifying that, then identifying what gesture it corresponds to. But as soon as we send our CAN message over to the vehicle, like, that's instantaneous, like 5 milliseconds, maybe, super fast.
That's good.
Yeah.
We have another question from Richard, and he asks if you have considered using infrared cameras to help with controlling at night.
Already in the product, yeah. Definitely a very, very necessary thing to have, yeah. Good
Amazing.
question.
Yeah. I also thought so. And it's impressive that you're using a mixture of machine learning, hardware development, and also high-speed cameras, high-definition frame rate cameras. So there is a lot of technology going into this. What is your initial investment and your projection of, financing this operation? Are you piggybacking on subsidies, or you're looking for backers? What kind of business model do you have?
So we've used a pretty good chunk of change for our non-dilutive funding. The government of Canada seems to really love us, so we've been able to amass a good amount with them. So now we're ready to. We've almost nearly exhausted that as a source, but we're still pretty connected with the Autonomous Vehicle Innovation Network, who are really interested in our product. They just don't fully know yet how to leverage it in the autonomous vehicle space. There's just still a lot of research to be done there. But they're a very good supporter of ours. But now we're ready. We're ready to kind of ask angel investors. As soon as we're kind of in the middle of the beta testing, as soon as we've collected enough user data, then I think we'll have a bit more traction.
And so do you have IPs? Do you have did you write patents? Do you protect your IP?
Yeah. So Sanjay, you wanna comment on that?
Yeah, so we've actually filed like provisional patent a couple ago. That was I think 2019, right, Hanna? That we filed that. I think so.
2019 September. Yeah.
Yeah. So we filed that, and obviously we have a year to do the full application, but we didn't end up doing the full application in the year, just because at that time we didn't really have anything that was novel, right? Like
yeah, we found two similar
shelf.
patents.
Yeah.
That kind of talked about the generalities that we introduced. One was by Audi, and another one I forget, but.
Yeah, so at the time, like all our hardware was off the shelf. The software was just open source stuff that we tried out. So we didn't really have anything special. So we didn't bother, moving forward with the patent at that time. We are working on two of them right now, actually. And one is for our own method that we've created for controlling the vehicle, like sending and reading messages from the computer network. And another one is for the new algorithm that we're developing for image classification, right? So there's two of them that we're going to be filing within the next year.
Understood. And that's a very interesting approach. And I know that is for a startup is a bit of a burden to try to write and protect your patent and IP. But you're doing it the right way. And I was thinking about how do you then develop your revenue streams if it is based on serving the automotive industry, or if you thought about also going consumer, if this kind of application could be used directly by end users, or you will be a B2B business.
Yeah, so I think that's a good question, Chris. I think I should probably explain how someone drives with hand controls. So in North America, if you have a disability and you want to drive, you have to actually go to a driver assessment center. I think Hanna mentioned that earlier, and you have to meet with these professionals, like occupational therapists. Their official term is certified driver rehabilitation specialist. So you meet with them, and what they'll do is they'll assess you physically and cognitively to see if you're fit to drive, right? And once they do that assessment, if they think that you're capable of driving, they will put you in their own vehicle with hand controls, and you're going to have to do a series of driving tests with their driving instructor. And if the instructor tells the assessor that, hey, okay, this person can drive with hand controls, then they'd go ahead and prescribe the hand controls so that the client can go and get it installed themselves. So, this technology is not something that you can just buy online and go install it yourself. You have to go through that entire assessment process. And it's like medication. It's like a doctor prescribes you the medication, go to the pharmacy, pick it up, same thing, right? So with that prescription, they have to go to a special mobility vehicle dealer, and only they can install this technology in the vehicle. So yeah, essentially for us, like our primary business model would be B2B, because we would be basically reaching out to these driver assessment centers and saying, hey, here's our technology and here's why we think you should be prescribing our technology to your clients. One, it's cheaper than the competitor, and two, it's way better, safer, more effective, right? So, these driver assessment centers, there's thousands of them throughout North America, and each one of them sees like hundreds of people a year. So, I think it's a very good way of making sales.
And do you think this could be also interesting, or have you been approached by people like DARPA or similar agencies?
DARPA, I've heard of them, but I just don't remember what they do.
In my view, this could be a military technology as well, because you couldn't use it only to assist, in driving with primary commands, but also could be used in military vehicles. Do you think this is something that would be out of your mission?
This is actually not the first time I heard this. Someone else brought this up to us before. I think Hanna, you were there too when someone brought this up to us. Yeah, honestly, we're open to this technology being used anywhere, right? I think right now we're just focusing on a specific market, but we're not going to, close our eyes to what other applications there are for this.
Some people have, there's this one group that that we're talking with, United Spinal Association, and the president of the tech section of that association, which is the largest group of people with spinal cord injuries in America. She is quadriplegic, and she plays video games with, I believe, I could be wrong, but I believe it's like a suck and blow technique. Like it's like there's a straw. Yeah, like, and so she's like, I use I can, use my facial gestures fine. If you made this and we beta tested this on like our video games, then it would bring so much joy to so many kids and adults and everyone. So that's one vertical that we're looking at. And then another one that somebody has kind of reached out to us about is hospital beds. So being able to control hospital beds using your facial gestures. So that's another one. So we're not closed off, but if the right opportunity comes, it's just a matter of, I think we got the facial recognition component down, but if they can help us with the other component, then it's okay. Then we can have that synergy, perhaps.
And it's great that you have a modular architecture so that you can, in case you don't use Canvas, you can substitute that element with whatever technology the interface is made of.
Exactly, yeah.
That's interesting. Yeah. And what do you think in terms of interfaces with other technology? What do you think about Maciej's technology? I think I asked this question at the beginning. Yeah. Now that you presented
well, actually, that's why I asked that question, because I was a little bit lost at first. I thought that it was an active, like, brain control interface, so I was a little confused. But now that I know that, maybe what we could do is we could record the person while they're playing the video game and also have that headset on and see whether or not the emotions that they might show on their face actually match up to, like, let's say, an avoidant state, right? Like a fear-based emotion in an avoidant kind of frame of mind.
Exactly. And in a way, driving a car is like a video game, right? So you have in a way, if you have a way of visualizing the feedback, right, you can see your avoidance approach reaction to driving a car.
Yeah, it would be like another way to corroborate your assumptions. Yeah.
Yeah, and have you thought about a flight simulator for your technology?
No, have not actually.
No, that's the first, Chris. Explain that.
Yeah.
What were your thoughts?
I mean, you can drive a car, but also you can drive a jet fighter, and there are some commands that can be actuated with the hands, and some other commands that there are so many secondary commands in an airplane.
Actually,
I mean, their control panels are insane. Like,
yeah, you know what? Now that I think about that question, so a good friend of mine, he actually used to be a pilot for Delta Airline, and he got paralyzed in a motorcycle accident, and obviously he can't fly anymore. So, for someone like him, this would be perfect. And I never even thought about that. Yeah,
but in theory, the sky is the limit, literally.
Yeah.
You just need to find the equivalent of the occupational approver professional group who are doing the signing off for the cars for the pilots, whatever that organization is, and partner with them.
Yeah, but in theory, there is no theoretical limitation to that.
That's true. Exactly.
Yeah.
Exactly. Many use cases for sure.
It would be good to start slow. Like controlling any of the primary functions, I would not even go close to that line, especially for a fighter jet. But maybe, it would be like similar to like a drowsiness detection in a car, detecting a state of panic or loss of consciousness. That's always possible.
So what about non disabled customers? Like, have you done any market research, or do you have any just general sense of, sure, like I can turn the indicator on, but maybe I do want to turn the windscreen wipers on with my face? Like, what are people's take on that? Maybe there's an interest in a kind of broader consumer base.
Yeah, 2 groups are new drivers. So I don't know if anyone here has ever remembered their first year of driving. It's like it was really hard finding where the wipers were or where anything was, like maybe first few months. So new drivers are kind of what we're looking at as one possible section of that, but also elderly drivers. So you wouldn't classify people of advanced age or elderly age as disabled, but they do have loss of cognition sometimes, or like it kind of, they do kind of lose a sense of cognition, but also lose a sense of physical control. So even the elderly have shown to be purchasing hand controls to control like primary vehicle functions, and as a result have started to buy these kind of secondary controls as well. So, or secondary, control, like they're buying like the buttons and the voice rec, but it would be interesting to introduce a facial rec system for them. And then other than that, it's that autonomous vehicle kind of hub. So if you're in an autonomous vehicle and you're operating or have to operate the autonomous vehicle, or let's say maybe you need to operate the radio or something's not working, say there are no controls, having this as a possible kind of addition could be good.
Interesting.
And to add to what Hanna said, actually, what we found is with new drivers and senior drivers, there's a lot of them that actually like to keep both hands on the wheel. And they have this anxiety, and they don't actually want to take their hand off the wheel to do things like, changing the climate or the volume or using their turn signals. Like they're just scared. So, in situations like that, they can keep both hands on the wheels and just use a facial gesture to control said functions.
Yeah, that was a great question, and John, that connects to the previous question of the business model for end consumer. If you have a, revenue stream that addresses this, anxiety in everyday's driver, that is also, very powerful. And also to come back to the question about the planes, if you bear with me, the DLR in Germany is an association that does research on automotive, but it happens to be the official aerospace agency. So they started as DLR Aerospace, but then they do a lot of automotive research. It's DLR stands for Deutsches Zentrum für Luft- und Raumfahrt, which is basically the aerospace technology center in Germany. And it's funded by the state. And I remember when I was in Oldenburg, Germany, doing my postdoc, that I basically spoke with some of the researchers coming, from DLR Bremen, and then around Germany there are many of these centers, and then we're trying to measure arousal from EEG, for example, to try to measure reaction times during drowsiness during driving. In case of drowsiness, and this is a same scientific area, but quite different use case from yours. But it's everything. I think I see that as everything is connected when you have an interface, a human-computer interface such as yours, that has a human on one side and a controller interface on the other side.
Yeah, definitely. The drowsiness detection is something that we're thinking of also adding. I just want to throw that out there as an additional feature. And it's been patented, so not too sure how that's going to play out. I don't know if people could target us.
I was curious about this actually, because I feel like there's so many people doing stuff in that space, whether it's with heart rate or facial stuff or EEG, right? Like it's you. It seems like I think I could list off like 5 to 10 people. So, and I don't work in this area particularly, kind of follow this, but I know loads of people seem to have been thinking about drowsiness detection. Obviously, it's a kind of application of sleep EEG. Makes a lot of sense from the point of view of things that are detectable and so on, but it's not widespread. Like it's not kind of penetrated. So I'm kind of curious, like what that space is in terms of, you know, multimodal or drowsiness detection kind of products. Is that something that there's a dominant market presence from some actor or other, or does nothing work? Or
yeah, I mean, one company that comes to mind, a big company, and they identify emotions. So fear, happiness, sadness, disgust, they have a difficulty with disgust and fear and differentiating them. But those emotions they recognize, and they have amassed millions of pieces of, millions of photos from paid ads. And their stuff works, but they seem to be more of like a research-based company. And I think it's a matter of how you market yourself. So yeah, you can have this technology, but what's your end, you know, goal? Who are you trying to help? Who are you trying to convince to buy your product? Yeah, I know what you mean though. It seems like a lot of this stuff is being developed and even being patented, but you don't really see it out in the market at all.
Either like it doesn't work, or it isn't useful, or as you said, like they haven't figured out what the marketing flavor that works is. But it is kind of curious, isn't it? Because it's been going on for a while.
It's very true. It's very true.
I mean, Alfredo says that Caterpillar has a lab looking at this technology.
There is a lab looking at this technology?
Correct. In the company called Caterpillar.
Caterpillar.
I'm sure like every, I don't know about Caterpillar, but like every major car manufacturer will have like one guy doing drowsiness detection with EEG in a research lab somewhere. I'd be 100% certain of that. But where
I guess at that point we were talking about emotion classification with face expressions.
Right.
And that's also something that came up with the neuromarketing stream, right? So when you look at products and then, you know, you classify your propensity for, you know, being aroused by the product, being happy about the product, or being, you know, negatively affected by that. I guess this is a completely different stream from yours, but it's also based out of the same, you know, pickup technology, I guess, which is cameras trying to gather facial expression and classify them into something. But then use case is different.
Sorry, and some company, I'm just looking on my phone right now. There's one company, I'm sorry, I'm getting a little forgetful here, but it's a company that collected a bunch of photos of people's faces without their consent from shopping mall kiosks. Happened in Canada, and there was a huge lawsuit by the Canadian government against them. And I think they were forced to shut down. But it's also this kind of policy issue right now. Like how, I don't know if certain people or certain companies are just stopped in their tracks because of new policies surrounding how they collected their data or how they're trying to use their data.
Yeah, this is a great, actually, you know, you offer me the question that I want to ask you now. How do you deal with data collection and data privacy and safety? In fact, you're also tapping into sensitive data.
Yeah, so basically it would have to involve, if we were to collect data of our users, they would have to know. They would have to know that their data is being collected, and they would have to give us their full consent. But we wouldn't resell their data unless, not unless, like we're not going to resell the data, but everything needs to be put into a consent form. If it's not in a consent form, you're just like, I don't know, shooting yourself in the foot. You know, people have to be honest, I'm kind of a very big proponent of big data. And yes, I think that certain governments, certain companies misuse it because a lot of the issue here is privacy and not telling the user what the data is being used for. If somebody were to tell me that my face is going to be used for X, Y, Z, and I sign my signature on that page, that means I'm okay with it. But a lot of these companies aren't doing that. And then the surveillance is a whole nother issue. That's the police state is something else. But anyway,
surveillance or surveillance are big topics, right? And we know something about that. You know, through wearables, and I'm working together with Steve Mann here in Toronto. But there has been, you know, there is an incentive for companies to you know, stockpile data from users, and rather than not having that and not using them and only analyzing it online and then throwing it away, because this is not actually what the value is. The value is actually how do you collect data from a lot of users also driving cars, and then how can you monetize that? And have you thought about this aspect? Because probably also the data that you collect is as valuable as the technology.
Definitely 100%. Like, we've thought about this, especially from, I think somebody brought this up in the chat, but yeah, we have all this data from outside the vehicle, but there's not a lot of data being taken from the perspective of the user. So right before the pandemic hit, actually, I was supposed to work in a lab that collects first-person data while they're in a driving simulator, and then based on that first-person data, predict what the driver would do. So that's something that is a very new topic, and something we're thinking about. I don't believe in throwing data out.
I'm curious, like, whether people like you guys who are striking out into the startup and the kind of new tech space, whether there's like pressures from potential investors or mentors, or like the general industry is kind of like really pushing you towards having a kind of data product and data selling model, and if it's just like completely the done thing, or if it's maybe that there's a lot of like freedom to go your own way, and if that doesn't fit with your objectives, then you don't need to have that in the picture. Are there pressures like that? Do you have any sense of like what expectations are on
I think maybe the biggest, if no explicit pressures, if I'm being honest. I don't know about you, Sanjay, but I don't think we've had any really explicit. Maybe one thing is like, you know, there are so many opportunities. This is you can solve so many problems. So don't focus on the problem for people with disabilities. Focus on this other problem. And it's like, okay, that's just your maybe personal thing. But then another kind of implicit pressure, which is not really a pressure for me, is like selling data. I know in the startup space, like people I've been around with sold, let's say like person data to ads. Personally, that's where I draw the line. I don't ever want to be involved with the ad business. So that's kind of.
And that's one thing about if you think about telemetries or you know, heartbeats and Fitbit similar data. Well, the other thing is you know, you have you know, facial expressions and faces that are tied to identity as well, which opens up another kind of worms in terms of you know, not only ownership but also privacy. And this is combining all the regulations all together, if you like, into an IP, if you will go there one day. So it's something maybe that is a great discussion for another time. And we don't have any other question at the moment. John, do you think about a final question for Hanna and Shanjay?
Wow. Let's think about a kind of looking forward question then. So what is the rosy version of the future for you guys over the next 3 to 5 years? with the company?
Sorry, John, my connection.
Oh, okay.
is just breaking
I'll
up.
talk, 'cause
Sure.
I think we have the same vision, because we were asked this question today. So over the next 5 years is definitely capturing 5% of our market. So if we could help, it's a big number saying it out loud, but if we could help 40,000 people using hand controls, 5% of our market, you know, B2Bing it, so being able to cast that wide net, that would be surreal. And then also connecting with the original equipment manufacturer. Yeah.
And to get to that point, like, I don't know how many people you had. You said you had a developer as well. I don't know how many people you have in the company, but like, will there be many like phases of scaling to get to where you need to be, or is it? Do you think you kind of have the product more or less like you can do it with the personnel and the team that you have now?
We would have to increase our team size. Right now we have, you know, under 10 people, many of which are students, and I think everyone but one is a student. So that would have to change for sure. That's one big thing. And then figuring out how to, another thing we have to learn is also how to manufacture at a large quantity. So that's something that we're learning and talking about with our advisors right now. So those two major things, yeah.
I see you have a schematic behind your shoulders, right? It's probably something that you're working on.
No, it's not. That is a blueprint of a house, because my partner installs panels for buildings. So I wish that was something that was mine. You know, everything I have is on my computer. I wish I was a physical, like, kind of paper person, but I'm digital.
And on this note, thanks a lot, guys. There was an amazing presentation and so much content and so insightful about the possibility of this human-computer interface that you're developing both at the hardware, algorithmic, and software level. So a lot of work, great work, guys. I'm amazed to see all these technologies. And then the presentations today were so good and such a high quality. And we had a lot of questions from the audience. So congratulations. This is an amazing startup. And I wish you all the best.
Thank you for having us, Cris. It was our pleasure presenting today, and thank you, everyone. Thanks for the questions, comments, and thank you. It was fun.
Yeah, Cris, John, you guys are fabulous hosts. I'm very excited for the following podcasts. Thanks for having us today.
I appreciate it, and stay tuned. The next week we will have Larissa McCatton from Cognicity. Cognicity is a subsidiary of Baycrest Institute here in Toronto, and she will speak about data. She is working with behavioral data in old adults, and also she will explain about the behavioral test that you can take online for free with this web app that they are developing at Cognicity. So please stay tuned with us with our podcast, and then I'll see you everybody next Wednesday at 8:30 p.m. Toronto time.
See you next time, guys.
See you guys.
Been a blast.
Bye.
Take care. Good night.
Good night.
Good night.